Now that we have all of the definitions and we have the concept of object-oriented programming laid out in front of us, we can start talking about the actual act of designing objects. What does this look like? What is the design theoretically? And then how do we implement it in our language of choice, which is Python? So the first thing we need to talk about is designing objects. And there are lots of different languages and standards, like UML, which is a unified modeling language, which can be used to design objects at a very high level. This is something that you really need to start getting used to, is separating the design from the implementation. A lot of you are going to get to the labs and see an assignment and sit down and just start coding. Oh, I'll figure it out as I go. And yeah, you can do that. The problem is that you end up putting things down on screen and committing to things and really spending a lot of time and effort before you've thought things through. And I'm not telling you that you need a perfect design or that you have to have everything functionally laid out, or that this is not an iterative process. It is. You know, the software development lifecycle is iterative in nature. You implement what you can, you test it, you figure out what's wrong, you fix it, you implement what you can, you test it, you fix it, right? That doesn't mean that you shouldn't at least plan out a little bit. Okay. You know how textbooks have those little pithy sayings at the front of a chapter sometimes, inspirational quotes to kind of tie together the topic. One of my software engineering texts, when talking about design, had the quote that weeks of work can save hours of planning. And this is true. That if you sit down on a complex task or a task that is hard for you, right? Complexity is relative. And just start slamming out code without thinking about what you're doing and quote, I'll figure it out later. It can really divert you, as opposed to sitting down thinking about going, okay, what do I need to capture? How do I capture it? What are the behaviors? All that stuff, right? That high level design stuff, which is language independent. Sitting down, writing it down in some formalized way. It does not need to be UML, but just having a document that says, this is what I want to do. These are the actions that this object needs to do. This is the state that this object needs to store. This is a very practical, useful, and applicable approach to get your head around a problem. There's also that nice little side effect of once something's written down, whether you want to or not, your brain will think that this is concrete, this is how it has to be, it's written down, right? So changing it is sometimes a harder task than simply not having it there in the first place and inventing it the right way. All of that said, we are going to go through a process. We are going to use the UML, what's called a class diagram. Okay. This is as software engineering as we're going to get this semester, but I like this this diagram type because it does fully encapsulate and specify things that you as a developer need to know and be ready for at the highest level before you can start to implement your objects. So let's take a look. And the example we have here is a credit card. So our credit card class is defined as having the following fields. And these fields can be thought of as the aspects that define the class. Okay. So we have things like customer, right? Credit card has a customer name on it. Bank. Trust me, walking with a credit card and them swiping it and saying, I don't see, who issued this. Oh, I issued it. It's fine. Trust me, businesses want there to be a bank associated with the credit card. An account number, right? A way to differentiate the different accounts. A balance. How much money have you already spent? And a limit. Hey, what's the maximum amount that this customer can spend? Okay. So the first question is, these fields, are these all of the things that can describe a credit card? And the answer is obviously no, right? You could have, right, there could be an address for the customer, a type, right, a Visa or a MasterCard separate from the bank. There could be all sorts of other things that I'm not even thinking about. So why have I not included those? Is it because I'm lazy? No, it's not because I'm lazy. I happen to be lazy, but that's a side effect. Okay. Remember the concept of abstraction. We need to capture what we need alone. So we need to capture what we need, no more, no less. So I will tell you that the use case for this class is going to be a POS. A point of sale application. And if you thought POS meant something else, I'm with you, actually. The first time I read that in the textbook, I'd never heard of the acronym POS, other than in one very specific context. And I giggled to myself. Yeah, this application is going to be a real POS. And then I found out, oh, it means point of sale, like a cash register. Oh, okay, cool. So having these aspects might be more than our POS needs, might be less, but yeah, I think we can rock with this for now. So in this use case, as opposed to like the bank software, right? This could be everything that we need. If we had the bank software, we'd need things like address. We would need things like type, but we might not need bank because it's the bank. So some of you are probably thinking, fields? What are fields? Well, these are the things that we're going to be storing about our object that describe our object. So fields is another term for attributes. And in our code, our attributes will be realized as instance variables. Okay. And we've talked about the next step too, which is behaviors. Okay, behaviors, or in code, methods. And we can see that they're methods as well because we got the parentheses at the end. Right? Calling a method, invoking a method is object dot method name parentheses. Right? And some of these methods might have parameters, some might not. Okay. Well, what kind of things will we need to describe about our credit card? Right? What kind of actions will we need to get? Well, we need to get a customer or get the bank or get the account or get the balance or the limit, right? And this is one class of method. And we'll talk about the two different classes in a minute. Um, so these are uh, methods that will return some aspect of your object. But that's not totally interesting. We also would want things that might alter our method, that might manipulate our method, right? So we want to be able to charge on the card, right? We want to buy something with the card, or we might want to make a payment on the card. Right? Our POS system might have the ability to pay off some of the debt. So in order to do that, we need to take an amount to pay or a price of a transaction to add to the card. Is this perfect? No, probably not. It's good enough for us, and it's good enough for now, right? And this is where the iterative process comes in. Okay, maybe we need more information. Maybe we don't need more information. Maybe we need less. Maybe we need more behaviors. We won't really know until we get through one iteration. But this credit card class definition seems fully encapsulated. It seems internally consistent. Right? This appears from the design aspect to be a fully realized abstraction of a credit card for a POS system. So we can move ahead with our design process at that point. But we need a little rule of thumb. Right? If you want a rule of thumb when you're designing an object, ask yourself, what data describes this object? What data describes what I'm going to need to do? How does that data behave? How does that data and object behave? And does my design encapsulate all the data needed to define that behavior? If you said, well, I need to charge, right? For instance, hey, charge with a credit card makes all the sense in the world. But you had nothing with balance or limit. That's going to be a problem. You might not realize the limit issue at first. That might be something that you have to iterate on. But you'll go charge. Oh no. Oh, I need to be able to add, I need to add to the total that is on the card. Okay. So I'm going to add my balance. That'll be good. And then you go to implement it and you realize, oh, I can just put an infinite amount of money on this card. So the next time around, you might add your limit. Okay. This is not a perfect recipe. These are guidelines for design. Approaches that will help you design more accurate classes, right? And the closer you can get to accurate in your design phase, the better it's going to be for you. And then you can implement it and iterate faster, right? Skip a couple of steps of iteration. There is a tension and a trade-off between having a perfectly defined object and class at the beginning, but then spending way too much time on the design aspect, and having something that is so minimal that you have to iterate many times to get anywhere close to correct. And these are trade-offs. These are trade-offs.